Today we're going to be looking at place value. The decimal system uses base 10. That means that each higher place, higher up the number, as we go from ones to tens to hundreds to thousands, is 10 times greater than the one before it. So the tens column is 10 times the ones, the hundreds column is worth 10 times the tens, etc. It also means that there are 10 digits that we use to count up. So that means that we start with 0, then count to 1, 2, 3, 4, 5, 6, 7, 8, all the way up to 9. And then we move to the next place value up. So once we get up to 9, the next place value, we put 1 into the tens. That's worth 10 lots of those ones because the tens column is worth 10 times that of the ones. And we continue up, increasing by 1 each time in the ones until we increase, get up to 19. And then we go over to 1 more in the tens column. So if we have any number, we can break it up, break it apart and look at it in an expanded form, and that might be helpful for us to do some operations on the number, to work with the number and multiply it, divide it, add it, subtract it. So for this number here, 3,254, we've got 3 in the thousands column, 2 in the hundreds, 5 in the tens and 4 in the ones. That's exactly the same as adding the digit that we have multiplied by its place value for each of the digits that we have in the number. So it's the same as saying 3 lots of 1,000, 3 times 1,000, plus 2 lots of 100, 2 in the 100s column, plus 5 in the tens, plus 4 in the ones. You can also express it using what's called index notation or powers by having a look at converting this 1,000 to 10 to the power of 3. You can see that in 1,000 there are 3 zeros, and 10 to the power of 3, the number and the exponent that we're looking at is the number 3. So here 100 is the same as 10 to the power of 2, 10 is the same as 10 to the power of 1, and 1 we leave as 1. So either of these is correct. They are both correct, and one isn't better than the other in any way. This one requires less writing. Maybe that makes it slightly better. We can also use symbols to compare numbers. So some of the symbols I've got down here, down this side. So this symbol here is the equal sign. It means is equal to, or is the same as. So here, 1 plus 3 is the same as, or is equal to 4. If we put a line through the equal sign, it means it is not equal to. So 10 minus 3, we know 10 minus 3 is 7, so that's not equal to 6. Okay, so 10 minus 3 is not equal to 6. These are all number sentences that we can say and that we can use words and that are descriptive ways to compare numbers. This symbol here, it means is greater than. So we know that 100 is greater than 37. If we put a line underneath that kind of looks like one of the equals lines, modifying it and putting it on a slant there, that means is greater than or equal to. So 5 is greater than or equal to 4. We could make that still true by removing the 5 and putting a 4 there. 4 is greater than or equal to 4 as well. But if we were to have 4 is greater than 4, that's not true. 4 isn't greater than 4, it's the same. 4 is the same as 4, it's equal to. So we could replace that with a 4 there and it would still be true. This symbol here, which is the reverse of the is greater than symbol, means is less than. So 37 is less than 100. If we put that line underneath, that means is less than or equal to. So we can write here 4 is less than or equal to 5. It would be true as well if we put a 5 here. 5 is less than or equal to 5 as well. So that's true as well. These, and look, this symbol here, which looks like a bit like 2 squiggly lines for an equal sign, means is approximately equal to. So if we're looking at rounding or estimating, we can sometimes use this. So 997 is approximately equal to 1,000. So here we've got a few examples for us to look at. Firstly, write the place value of the digit 4 in the number 543,910. And our second question here is Write 517 in expanded form. So if we're looking at just the digit, in digit 4, we're looking here, and that place value there, if we look at, we have, here's the ones, tens, hundreds, thousands, and then we go to 10,000s and 100,000s. So it's in the 10,000s column. So that 4, that place value there is the same as 4 times 10,000. So here we have 4 times 10,000 is 40,000. For our second question here, writing 517 in expanded form, we've got 5 in the hundreds, 1 in the tens, and 7 in the ones column there. So that's the same as 5 times 100 plus 1 times 10 plus 7 times 1, which is the expanded form there. We can use the index notation or the exponent notation or the power notation, if you would like to replace the 100 with 10 to the power of 2, and also the 10 to 10 to the power of 1. Okay, so both of these are correct, neither is any more correct than the other.